let's now go back to the slides and do one more exercise together. All right, so I already summarized every point. Actually, I talk about more than the slides, but I would say still look at the slides and also together with my notes and illustration. That's always the most beneficial way or effective way for your learning. And this is a required written notes, which I I have made available to you. Let's now take a look. Okay, so this, if you click on the link, you are going to see that. Okay, it's about 5 pages to go over. So this one is about static types, expectation, dynamic types, and also typecasts. So you will see diagram that I similar to what I just visualized before, right? But I would say my diagram over here is actually very detailed. But definitely, you want to combine all the resources that are made available to you. Okay, about 5 pages. This will be required reading for your upcoming written tests and also for your exam for sure. So please take a look at that and go over them. If you got any questions, reach out to me. You know how to do that. Okay, so just to emphasize, you do have some required reading to actually supplement your lecture. All right, let me just move on. Okay, let's now do one more exercise together. Okay, so there are 2 parts for this exercise over here. For part number 1, I'm also trying to prepare you for the written test and also exam for later. Based on the Java class declaration, let's say we got one class A, we got 4 classes, we got A, B, C, D, and you can see B extends A, C extends B, and also D extends A. Based on the extends relationship for the inheritance, can you visualize the hierarchical diagram like a smartphone or like the student classes? Can you do that? All right, that'll be part number 1. Why don't you pause the video and do part number 1, and then I'll meet you in my iPad notes. All right, assuming that you have thought about it, let's now take a look. This should be the diagram you actually derive based on the inheritance relationship over here, right? You can see A is the root of the hierarchy, B extends A, C extends B, and also D extends A over here, right? So that's the diagram you should at least be able to infer. And in the actual written test or exam, you might get a larger number of classes to actually derive. So you better make sure you know how to do that. Okay. And so now I want to do the next part for the exercise. For these 2 lines, I would like you to judge to see whether or not they will compile. We're only talking about compilation. Okay, let me now write it down. The first part will be compilation. Okay, for compilation, and think about your answer by pausing the video. All right, assuming that you thought about it, let's say line number 1. So line number 1 over here, does it compile? The answer is it does, because over here you can see the right hand side, the dynamic type is actually C over here. You know what? Let me just maybe use a better color. Let's say C over here is dynamic type over here. That's a C. Let me just draw better. Okay, that's C. And then you can also see the static type is actually B, right? That's a static type. Static type. And can the dynamic type fulfill the expectation for static type? Indeed, because C is a descending class of B. All right. It is okay because dynamic type C can fulfill the expectations of the static type B, because C is a descendant class of B. The descendants of B. Right? That's also similar to what I did earlier, but I think since it's an exercise, I will rather give you some standard answer, which I will expect from you. Okay. You talk about dynamic type and also static type, and also we talk about fulfilling the expectation. And the way to judge is by whether or not it's a descendants. Okay. What about line number 2? Line number 2 will also compile or does not compile. Well, line number 2, there are 2 parts over here, right? Let's talk about this part over here. This is a cast. All right. It will be valid if it's either, right? Remember our summary over there, right? You can see either it's upward casting or it's downward casting with respect to the static type, right? If it's either upward or downward casting with respect to the static type, which is B. All right, so now if you look at the B is over here, static type. If you want to do upward casting, the only class you can do is A. If you want to do downward casting, the only class you can do is C. So these are the only three classes where you can do compilable cast. But now we are trying to cast that into D. So that's not good, right? So that's why, no. Because the cast type D is neither an ancestor nor a descendants of, so the variable we're talking about is B, by the way, okay, of B's static type, which is B. Right? It's really important, again, to really see the principle, right? The cast type over here, neither an ancestor nor a descendant of the static type, is with respect to the static type, since we're still talking about compilation. However, if you, of course, this one already caused you the compilation error, right? But of course, if you look at D and D, of course, this one is okay. But since you already got compilation here, so already here, so it doesn't make sense to really continue to analyze. All right, so that's about compilation. As far as compilation is concerned, you got error at line number 2. All right, so this is the second part of the exercise. And the third part, which you will also see from the slides, is let me suggest the following cast in place of line number 2. Let's talk about some alternative. Okay, let's say alternative to line number 2. Okay, let's try the following. What if I say the following? Let me write it down, and then you tell me whether or not you actually compile. I still got D over here, and then D. And then what I want to do is I want to do some nested cast exception. Oh, sorry, nested cast expression, not exception. Beg your pardon. I want to do some nested cast expression. First of all, I want to cast B to A. And then I want to cast this expression over here into D. Alright, so let me just show to you some syntax over here before we go further. The first cast to do is to A over here. And the second cast to do is to D over here. Right? So the question is this valid or compilable? That's really first of all, we ask about compilation only, and then I'll ask you about the runtime. Let's one thing at a time. Sorry. Okay. While I'm fixing this, why don't you tell me? I want you to think about it. Valid and also compilable. All right. The answer is it is going to compile. Not a problem. But you can let me just try to show you what I'm trying to do over here. Right. It is valid. What we are doing is we are trying to do, and from the static type, we're trying to really traverse the diagram, right? You can, let's say this is static type, this is a cast type, which I cannot do directly, which I cannot travel to directly. Why don't I travel there indirectly? So what I do is I try to upcast to A, and then downcast to D. To be honest with you, what we're really doing is, let me just present this a little bit more abstractly to see if you can understand it. Imagine that this is the inheritance hierarchy that we have, all right? Let's say I got some static type over here, and somewhere along some irrelevant branch, I got my cast type over here, CT, right? And I always have a way, I always have an algorithm to really cast from the static type into the cast type, I always got a way to do that without any compilation error. All I can do is I can always cast upward casting. Let's say I can always do upward cast into over here the root of the hierarchy, and then I will do downward casting to that particular cast type. That's an algorithm that will always work as far as compilation is concerned. And to make it even more general, let's make some connection here. What's the top of the hierarchy in Java? Objects, meaning that I can easily cast from one class to another completely irrelevant class by upward casting all the way to objects and then downward to that particular type. I'll give you one example. I'm writing this doesn't really mean you got to do it, right? I'm just showing to you. It will compile. You can try that. For example, let's say, for example, okay, let me maybe use pink. For example, let's say let's just use your one of your lab for as an example. Remember, we got a class called vaccine, right? Vaccine is for your lab number 2, and also we got a class called flower for your lab number 3. They're completely unrelated to each other. I can cast from vaccine into flower by making that compile. Okay, how do I do that? Let's say flower over here, F is assigned to. So what I can do is, eventually I want to downcast to vaccine. Eventually. And the way to do it is to make sure I first upcast to objects. And then I'm just going to have my vaccine. Oh, sorry. I beg your pardon. Let me do it again. Eventually I want downcast to flower. And then, so this is what I have. Okay. Okay, let's see what we're doing here. So basically what I'm doing here is, so I got some vaccine objects V, right? Statically, it's actually vaccine. Okay. So what I do is I first of all upcast to objects, the top of the hierarchy. So you can think about this part here as vaccine, and upward casting to objects, and then I can downward cast into flower. So everything is actually valid, because remember we said a cast will be compilable as long as it's either upward or downwards, or like a combination of them. So that's why I can arbitrarily cast from one to another if I know the trick about this algorithm over here. All right, so that's about why this will be valid. But the last part of the exercise, are we going to run into any exception at a runtime given that it's compilable? Okay, so that's the final part over here. So you can think about this part. This is part 2 of the exercise. Well, apparently part 1 is about drawing a diagram, right? And part 2 is about analyzing compilation. And part number 3 is about the whether or not the alternative line for line number 2 will compile. And finally, part number 4. Part number 4. Given that this line over here will compile, are we going to run into any exception? Indeed, we're going to, because you can see if we managed to actually cast into eventually this type over here, D. Manage. That's what we managed to do. D over here. Okay? But now, at the runtime, when we actually try to cast eventually to D over here, eventually, so dynamically it's C. Can C fulfill the expectation on the cast type, which is D? The answer is no, it cannot. So that's why we're going to run into class cast exception. Okay, so class cast exception, because dynamic type of B. Oh, let me write maybe slightly briefer. So B's dynamic type, which is C over here, is cannot fulfill the expectations of the cast type. The cast type is actually D, right, over here. Okay, one more thing to say. Another way for you to argue that, you can it more precisely, okay, for this part over here, more precisely, and this part we cannot fulfill because the cast type D, the cast type is not a descendant of B's dynamic type. That's also what we said earlier, right? We talk about here compiles, but class has exception, but it's actually not ancestor class. Okay, you know what? I said something wrong over here. What I meant to say is ancestor. Beg your pardon. Okay, I'll visualize again. Sorry for saying that wrong. It's really important to get it right. It's not an ancestor. It's not an ancestor of the dynamic type. The cast type over let me use a different color. Okay, the cast type over here is not an ancestor of dynamic type, which is over here, because D is not an ancestor of C. That means C cannot fulfill its expectation. That's as simple as that. C can only fulfill the expectation for its ancestor, which can be either itself or B or A. So now we talk about D. D might simply just contain some additional expectation like an attribute or methods which C cannot support, right? That's very normal for the inherited classes to actually define, some new attributes or methods, as we said before. All right, so that's about these 4 parts. Let me just highlight them again. So you really want to make sure you actually understand about each part, okay? So let's now try to highlight it. So we got part number 1, we got part number 2, we got part number 3, also we got part number 4. So please make sure you understand each part of this exercise over here. All right, so that's about what I want to discuss about typecasting, right? That's about some short summary of what I just said. And the next topic will be, given that we might run into class cast exception if the cast type is actually not the ancestor of the dynamic type for the variable that we are trying to cast. Is it possible to do some to really create some safety net that we might fall into at the compile time? Is it possible? Or at the runtime, we can actually put something to make sure we only do the cast when the cast type happens to be the ancestor for the dynamic type, which we know in general cannot be inferred by the compiler. But as a programmer, we might just want to do some manual check by ourselves. That's something we'll discuss next, which is the instance of operator.